In this video, we're going to talk about measures of the location of the data and how to make box plots and what the 5-number summary means. So in your textbook, this is in 2.3 and 2.4. So since we use technology for the most part, we're not going to go through the calculations by hand. I will post some extra videos if you're interested in that, and also in your textbook you can see where all that is and if you want to go through that process, but it's really not necessary. We've talked about some of the other measures with histograms, frequency polygons, and things like that we use pretty commonly. Histogram probably being the most used. When we talk about box plots, we're going to need to use quartiles. So first quartile, second quartile, third quartile. So we use subscripts 1, 2, and 3 to represent that. Quartiles would be talking about 25%. So when you have the second quartile, it's 50%, third quartile, 75%. So it just divvies it all up. And then we have the minimum and the maximum. And that's basically some really key points for us. Median would be the center. So just think 50%, that's our middle value. A way to find that is to take your smallest and your highest and put them all in order, smallest to largest, and it's the middle value. But if you have two middle values, like in this data set here, you could actually just average those and get it that way. Or you can just use the software. You can use StatPlot or GeoGebra. I'm going to show you a little bit of that today as well. So I'm not going to go through by hand how to sort that because we'll be having bigger data sets. One thing we are going to look at though is the interquartile range and how to find outliers. So we'll be looking at some problems with that. So I'm going to switch over to our worksheet here. And so just what the meaning means of it, percentiles. We've heard expressions like Ryan scored in the 90th percentile on the exam. So just to be clear, it's not that that's what they averaged on the test, like how much they got right or wrong. It's how they compare to the rest of the group. So, and you sort all the data, Ryan's score was higher, at the 90th percentile than 90% of all the other people, or you could say top 10%. So we often use K as a generic to talk about kth percentile and the subscript K, P sub K. Again, we're going to really be looking a lot at the 5-number summaries and box plots. So it'll be split into each 25% chunk. So for example 2.7, the Graduate Record Examination, GRE, is a test required for admission to many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admission into their Human Genetics MPH or MS program. Interpret this admissions requirement. So you'll see some things like this in your homework, and really just simply saying not they got a 70% average on their test, but it's saying they were at this above that 70th percentile or at or above. So the top 38%, you could say, of the group, which is probably pretty high marks because they're all smart people, right? So it's relative to the other people. So just keep that in mind when we're talking about percentiles. So you might want to just jot the answer down there. Students must score at least or better than 70% of all scores on the GRE. So that's just the way to word it. So a lot of it's semantics, but it really does make a big difference. If you're talking about I got a 70% on my test versus I was at the 70th percentile. So remember, it's relative to the group if you think about percentiles versus percentage. So I hope that helps clarify that. And so then our scores we're going to be looking at for data are relative to the group. So when we're having whatever data, it's not just, test averages or things like that, but any data, we can divvy it up into chunks of 25% because it kind of makes it easy to see that way. If you look at this visual, we have the smallest data value down here. A lot of times we're going to call these box and whisker plots or box plots when we develop the whole graph. But for now, we're just looking at like this number line, generic number line being split up into 4 pieces. The median being right in the middle. Q sub 1 would be the same as P sub 25, 25th percentile. Q sub 3 is the 75th percentile. We don't really talk about like the 0 and the 100. We talk about it as minimum and maximum. One of the important things here we want to look at is this interquartile range. I'll highlight that. That is the third quartile minus the first quartile. Okay, so we want to look at this chunk here. And that's what when you make a box plot, it goes around that area. And we'll show how we use that momentarily. So again, our key values are the minimum, Q sub 1, that'd be a little subscript there, Q sub 2, so it's not Q times 2, it's sub 2. So let's make that more clear on here so you can see it. Q sub 3, 75 percentile, and then maximum. That's the highest value in our data set. So let's revisit this data we looked at before of 16 randomly selected weights in pounds of models from a model agency. Find the 5-number summary and include the interquartile range. Wow, that's quite a range. Pretty low on some of these. So what we're going to do is we're just going to go ahead and put it right into Stapplet. So see if you can pause the video and try that on your own. You're going to highlight this. You can copy it. I already have it set up where it's just spaces in between. And then we're going to go into our Stapplet online. Just a little refresher, just type in stapplet.com. This will pop up, or you might have to search or whatever to get it. And then we're going to do a quantitative variable single group. And then we can make this a little bigger for you. Variable name. And then the raw data is what we want. And then click in the box and do Control V to paste. And then begin analysis. And remember, it's always going to give you that dot plot, which we hardly ever use, but it kind of shows you. It's actually a little bit nice because you can make sure, like, oh yeah, I got all my data in there. You can have it automatically show box plot, or from the drop down menu, click box plot. And I have my axis labeled there. That's actually more of the title, so I'm going to go ahead and change this. And I'm going to put, actually before, number of pounds. So that I have a description. This doesn't have a spot where you can just add a title at the top, so I'm being more descriptive here. And then I might need to redo that, just hit that again. And oh, we got a typo, you can go back in there, and then I can just hit begin analysis again and it'll fix it down here. You don't have to go through the drop down menu again. So this is our box plot. And it's really nice picture. It shows you that, you know, a lot of the front of the data is on the lower end. And then we have this high value. And then we're going to look at, like, how do we know if that's an outlier or not? Here's the minimum. You can also hover here and see what your first quartile is, 91.5. We round to one more place and the data is given in. And then we can hover here. See, 110 is the median. And then 115 is the third quartile. And I can also see those numbers here. If I look at summary statistics, I can see my N is 16. I can see my mean. So that's also important that we'll be using in a lot of things. We'll go over that later in another video, but that's where you're going to find your mean is in this little summary, and your standard deviation 16.898, and this is your 5-number summary. Min is 85, first quartile 91.5, median 110, third quartile 115, maximum is 138. After that, down lower, we'll look at those things maybe later in the course if we get to that, but don't worry about that right now. So if you were going to show your work for this, you could do a snip of this and just save it on a separate sheet and submit it. You could take a picture of your screen with your phone, submit it. You could sketch it out, those kind of things, just so you have a record of what you did. You have an example. I can see your work for things, especially on quizzes. It's going to be convenient to submit it that way, or activities and things. Okay, so I'm just going to switch back over to the worksheet. For this problem, though, it doesn't ask for the full box plot to be drawn out, so we could just put our answer here and just write it down. The next part here, we're going to check for outliers. So we're going to use the quartiles to do that. The IQR, interquartile range that we talked about earlier, is really important in figuring that out. So we would take our lower fence, we call it. We never draw those, but we just use that as a tool. We figure out that number, and we're going to subtract off 1.5 times our interquartile range. That will be our lower fence. And our upper fence is the third quartile plus that 1.5 times our interquartile range. Okay, so if we think of our example from up above, we have our interquartile range would be the third quartile, which would be the 115. Let me see if I can fit that in here. Let's write that right in here. 115 minus the 91.5. So that is going to equal 23.5. So you can do this along with me. So this is my IQR. Okay, and the next thing we want to figure out is 1.5 times that, so we can get what we have to subtract off and what we have to add on. So we have 23.5 times 1.5 is what we're going to figure out here. And we get 35.25. So that is not the answer. The answer would be what we're going to, I'm just going to fill these in here. We're going to calculate out the first quartile minus the 1.5 times our IQR, which we got was 35.25. Okay, so we get, let's see, that should be a 6 there. 56.25 for our lower fence. And then we could do the similar thing. I'm just going to copy in the same model here. So we're going to have, instead of 91.5 though, we're going to have the 115. And we're going to add that 35.25. And I will get 150.25. And those are my fences, so that's the upper fence. Then we're going to look back at our data here. If we have anything lower than 56.25 or above 150.25, then that's considered an outlier. So the values we have here for minimum and maximum are within the fences, so we do not have any outliers. And again, we don't draw any fences on box plots. However, we would put in outliers if we had them. So when we have those, I'll show you that in another video. So that is it for this one with looking at examples. We've already answered this question here. We could just say no based on what we came up with. In another video, we're going to look at percentiles, quartiles, and median in more depth, and looking at the frequency table. And I'm going to show you how that looks in GeoGebra, because that's pretty nice, but I'll do that in a separate video. Have a great day.